Thanks, Gary. So since time is short, I'll quickly move on. You'll get to see the point of me using shrimp in a moment. So, I actually came from WA, and you can't help but notice when you're there that there's a major feature sitting offshore Perth, and it's called the Perth Canyon. It's probably the biggest deep-sea canyon on the Australian continental margin, and apart from occasional multi-beam data when ships went in and out of Fremantle, very little was actually known about it. I won't try and go through all those points since time is short, but it was actually also an MPA that was flagged by the previous government to be zoned with not fishing exclusions and so on. But surprisingly, almost, as I say, nothing was known about it, particularly for its deep-sea coral environments, or what was there in the deeper waters. Being a canyon, of course, you would think that that's a fundamental feature, but essentially there was no real knowledge of what was down in that canyon, apart from a few trawls on the very bottom floor, nothing known about what was on the walls and so on. So with the Schmidt Ocean Institute, which is funded by Eric Schmidt and his partner, he's the CEO of Google. We were successful putting a proposal in, getting the ship across, and they put on their ship act. So this ship's about an 80-metre vessel, 87 metres. It's the Falcor. They put an ROV on the ship. That crane is actually bolted on. Interestingly, from WA's viewpoint, that ROV was a local tool that was used in the gas industry, but such tools have never really been used in this context before, at least on our coast, and very little in Australia. But of course, in other countries, this is a routine tool to have an ROV. Australia yet does not have this research capability available. Anyway, we went along and put that on. I should point out the team is large. We had the crew, we had our students and postdocs, we had some visitors from overseas, and it was really a big team effort. We were out there for about nearly 2 weeks. Every day was really full on, and it was, without this team working together, we would not have made the discoveries that we did. So this is what the canyon looks like if you imagine from a plane. You can see a rock nest in the background, and then further back is Perth itself. It sits right on the edge of the continental shelf. The bottom part of that canyon gets down to 4 kilometres, and it starts at about 600 metres water depth. This is what it looks like from a plan view. The deep blue is, as I say, about 4 kilometres water depth. This is a fly-through, and you can actually get the impression, it's a bit jumpy, I apologise for that, but you can kind of get the impression this is like the Grand Canyon, but it's sitting under the seafloor. You can see very steep walls, narrow valleys, and some features that are very reminiscent of what a sort of fossil river or a fossil Grand Canyon would be like. I'll show you some of these. We actually targeted with the ROV some of these very steep-sided walls to see what was actually down there. There's a few random little spikes, peaks, which are just random data points. Okay, oops, no, it still goes. And you're zooming into some particular spots. It's a bit of fun playing with these kind of things. This is just all we gathered this multi-beam data at night, so the ship cruised up and down about 1,500 kilometres, so while we were sleeping, it gathered this data, and then the analyses were done. Okay, look, because time's short, I'm just going to talk about a couple of sites. I'll show you some pictures, and at the very end I'll go through a video, and you can decide whether you want to stay or not for that. So we looked at site A and one of the other sites, I think it was B and C, but I'll quickly go through these now. I'll just show you some pictures of this. So this is a site A at the top of the canyon, closest to Perth, and you can see it's the red area is about 600 metres and the blue is about 1.5 kilometres. This is just some pictures from the ROV itself. You'll see some of these in the video. You see a bivalve, a Kester. On the bottom right-hand corner is a very long-lived black coral we found attached to the walls. And you can see the blackness. We have very strong lights on the ROV, but these walls are totally vertical, and you're really looking down an abyss. And there's a little sampling device that we used. We did discover there was a sea glider that had disappeared down the canyon, and we saw it, and actually I'll show you, it actually got wedged under one of the canyon against the wall and was snagged, if you like, or caught there. What I was particularly interested in the bottom, showing some of these deep sea corals, Desmophyllum dianthus. These are solitary corals. We found clumps of these living together. Another site. This is a calcitic coral. I think it's Narella is the name. There's our sampling device. We found bits of life attached to certain parts. And I'll show you, we also we found this sort of fantastic assemblage of these silical glass sponges, and you can see trapped inside it there are these shrimps, which are actually more or less trapped for life there. There's a close-up. We had fantastic, the cameras had really super high resolution, so you could really zoom in and see exactly what was happening. One other site. This is part of the very steep-sided canyon. You can see the cross-bedding in some of the sediments. On the top left-hand side, you can see a Venus flytrap. What we did find was we did have kind of corals or different types of corals present. They would sort of be very tight aggregations. Everything was in one spot, like little tiny hotspots of life clinging onto the sides of this canyon wall. We also did some geochemistry on the waters. So this shows the temperature salinity plot with depth down to about 2 kilometres. And you can actually see the top part shows the clear, distinctive salinity temperature fingerprint of the Lewin current. The interesting thing on the left is we measure the pH, of course. You can see as you get into deeper waters, the pH decreases. And the interesting thing, of course, is that the saturation state for both aragonite and calcite in these depths gets quite low. So it's getting close to, for aragonite, almost undersaturated at 1. For calcite, it's about a factor of 2. So one of the reasons I was interested is that we expect as CO2 is abducted or sequestered into these deeper waters, these curves will change with time, and this environment is in fact particularly sensitive to acidification as the saturation curve will decrease with time. What I'll do now is show you a 5-minute video, and you can just stay and we can just start the video now if you like, and that'll be the end of the talk. So you can decide if you want to stay for the video or just go to have some coffee. But this is the video taken directly. This is actually from the cameras, and you can just watch it. If you have any questions, I'm happy to answer them about the video.
Oh, thank you, Malcolm. Everyone's fixed watching the video. That's fantastic. While you're watching it, I've just got two quick announcements. Sean Connolly asked me to announce that there'll be a Program 2 planning meeting at 6:30 tonight in the Harbour View 1 in this building. And secondly, Jenny's just given us permission to have 5 minutes extra morning tea, so the next session will start at 11:20 rather than 11:15. So please enjoy the movie, and thanks to all the speakers. A very interesting session.